This is CCS America's series, Let's Talk Lighting, where we get technical about machine vision lighting techniques and technology so you can solve lighting challenges more efficiently in-house. I'm Emily Ting, marketing specialist at CCS America and co-host of this series together with the wonderful Lindsey Sullivan, our technical marketing manager, who is here to share all her knowledge and experience from her time as an application engineer. Lindsey, how are you doing today?
Doing well. It's Friday. I always love to say happy Friday. So it's a good day. How about you? How are you doing?
Oh, we talked about this morning. I am like in the preventative worrying phase of like, I'm about to go on vacation during the week of Thanksgiving, and it's just like, gotta get everything done before then and gotta finish getting ready for my trip. And so, anxious Emily is like out and about and she's coming up.
Sure, everything gets done. I feel like I didn't used to be this way, but now when trips come, I'm like anxious until the flight takes off. Like something's gonna go wrong.
Oh, yeah.
I won't be able to go. And like I've never been able to not go on a trip that I wanted to go on, and yet still.
That's how I've like experienced trips my whole life. It's just like anxious up until I'm in my seat. And at that point, it's just like, there's nothing I can do anymore. I'm like in the hands of fate. I can just shut down, short circuit, just like for a while until we land. And then it's my problem again.
For the next 2 hours is not my problem. I actually really like that. One quick just vent. I think it's so funny when people say have a safe flight because I have zero control over the safety of the flight. There's absolutely nothing I can do. Like you can wish it upon me, like have a safe flight. Okay, I'll try. I hope so too. I always think that's
Hopefully, your
funny.
flight is safe.
Yeah, that's what I think people should start saying to me.
We'll try and get that rolling. Maybe we need to put that little bit on TikTok and it'll go viral and we will start a movement.
Yeah, maybe our next top landing is just going to be like airport, like venting, like airport. Gosh, what's the word? Protocol. And like, yeah, you know what I
We'll
mean?
start a new podcast about our commentary on airport experience.
Just general venting. Today, we're venting about airports.
Yeah, so look forward to our future podcast on airports. But today is a podcast about machine vision lighting.
Back to why we're
So
here.
let's get into it. Yeah, let's get into it and talk some lighting, specifically about a certain type of unwanted lighting, which is glare. And you could argue this is one of the main reasons we have machine vision lighting at all in existence, because it's there to solve for removing unwanted glare that interferes with seeing whatever you're trying to inspect. So that's why we have machine vision lighting, guys. That's our pitch to you of why to buy our product instead of that random generic halogen lamp at the hardware store. That's why we have machine vision lighting. Strip of LEDs, Halloween lights, stuff like that. So yeah, there's two types of glare that you encounter, the kind caused by machine vision lighting itself, and then the glare that's caused by ambient light, aka the overhead lighting in your facility, the overhead lighting reflecting off of other surfaces in your facility. If you're by a window, the ambient light from the sun coming in and sometimes interfering with your inspection system as well. So those are the two main types, and we're going to just talk all about understanding two different types of glare and how to solve for them. So first question for you, Lindsey, is when you see an image and you see a bright spot or a hot spot, it can be unwanted glare. Sometimes it's specular reflection from bright field, which is what you want sometimes in some applications, or it could be oversaturation in the image, and then it's not necessarily a lighting problem. So how do you distinguish like what type of, brightness you're looking at? And if it's unwanted brightness, how do you tell like what's the problem? Is it glare or something else?
Yeah. So that was a really beautiful intro, by the way, of explaining all the differences. Well done. So it's interesting when you see an image, a lot of the diagnosis is done by being able to like modify it. So if someone is just like, is this glare or, oversaturation, you can kind of tell just by if the light is coming kind of like from one side of the image. Oh gosh, I'm like explaining this poorly. In a weird sense, you can kind of just tell by looking at it. But if you're playing with your image and you see like a really bright spot and you kind of want to know where it's coming from, you can start by adjusting the exposure time of your camera or the aperture or the intensity of the light. And if you turn that down and the hot spot goes away and becomes a more even image, that's when you would say, okay, this is just oversaturation. And oversaturation can be bad because it hides details. So if you turn on your aperture all the way and your image turns completely white, that's obviously an oversaturated image. You're not seeing anything if you turn in. So the kind of rule of thumb we have to avoid that is in your area of interest, because sometimes the image itself is oversaturated, but where I'm looking isn't oversaturated. So in your area of interest where you're going to like put your tools and inspect, you want the brightest spot to be about 200 out of 255. So you can kind of make sure that your whites aren't super white. There's sometimes they have to be super white to see the other stuff, but just know that the more white you make everything, the more oversaturated you get, the more likely you are to hide details that you don't mean to hide. So to find out if it's oversaturation, you adjust settings on your camera or the intensity of your light. And then kind of the difference between, specular reflection and unwanted glare is they're both the same thing. They're both the light hitting the sample and going directly into the camera. The specular reflection is what you said, though, where we're purposefully capturing that to get the bright field image. And so the scratch or the, embossed coat or whatever is going to diffuse and then it looks black to the camera. To find out if it's glare and that's the problem versus oversaturation, that's when you're moving the light around to see if the glare moves on the product. So if you have an oversaturated image, it'll probably stay consistently on what part of your image is oversaturated if you move the sample around it, or if you move the light around. If you have a glare on your image, the more you move it around, the glare on the spot should change. So pretty much that's kind of it in an almost bad way of describing it, but that's kind of it.
I think you should give yourself more credit. Like the ending summarized it up well, where, glare, you can tell it's glare because if you move the light around, it will move with the light. If it's oversaturation, it remains static, essentially.
For the most part. There's always a caveat.
So I think you summarized it pretty well. Give yourself a pat on the back. And then, so you said to test for oversaturation. I see you or the engineers in the lab and you tune or you adjust the light intensity or the aperture. And I guess that's like fine in a lab setting, but those aren't necessarily the settings you're going to be using in the actual application. I guess, do you give customers like special instructions, in the report or whatever, or is it just on, I don't know, the end user or the system integrator to fine tune it on site, the aperture and the light intensity?
Yeah. So, I mean, it's close because it's all dependent on the exposure time because we have to make sure that we are having enough light for whatever exposure time the customer needs. So when we're doing our testing, we'll set our camera to, I like to do a little bit under what they want. If they need 500 microseconds or something, I'll do 450 milliseconds. I'll do like 450 just to make sure I'm giving myself the buffer. But like you set your exposure time to what the customer has if they've given the value, and then you adjust the light intensity and aperture from there. And there's the trade-offs of adjusting the aperture. Does it have to be more closed to get a big depth of field or more open for more intensity? Does your light have to be overdriven to meet that exposure time? So we, it might not be exactly where like we put our aperture to f4 and then they'll put theirs to f4. Like they'll fine tune it a little bit, but for the most part, we're giving them a good ballpark of the light has to be at, 80% intensity to see this. And the aperture has to be pretty open to meet the exposure time that you want. So we kind of give the ballpark and then they fine tune from there.
Okay. I was always curious because you hear about like, oh, you test in a lab setting, but the reality on site is so different. And to me, that's one example of how what we come up with in our testing is not what you like copy paste into the actual environment.
Yeah. And sometimes people don't give an exposure time requirement, like it's a stationary, or they have a lot of time and it's not really moving. So then I'll just put like, if I don't have a requirement on what the exposure time is, I like to put the light at 80% intensity and then whatever exposure time that gets me, just because if the rule of thumb, if you can do that, eventually the lifetime of your lights kind of decrease over time. But if you set them at 80%, as they decrease, you can just bump up the intensity and you kind of get 20% more out of your lifetime of your light by doing that. So I kind of like to say like, hey, if you can meet this exposure time of, 100 milliseconds, then your light will last a little longer.
When you know, okay, the problem is glare. There's, like we talked about, there's the ambient glare, machine vision glare. Do you have to approach solving those two differently?
So a good way to kind of think about it, ambient glare is kind of like a contamination problem where there's something from the outside that is kind of not really out of your control, but a little bit is getting into your image. You don't want it there. Versus machine vision glare is more of a design problem. And so you can go about solving them differently, because if it's a contamination problem, you have to stop the contamination, which is usually by blocking it, shrouding it. Is going to be the first and tried and true method. You can't really, it's not going to get past blocking the light, right, for the glare and the ambient light. You can also overpower the ambient light by just increasing the intensity of your machine vision light. And a good way to test if that is happening or not, so if ambient light is your problem, if you're overpowering it, there's two ways. There's one way if you have your light on and you turn off the lights, like if you're in your lab and you see a glare and you have a hot spot and you turn off the lights in your lab and you still see that hot spot, then that's a machine vision light problem. If you have it and you turn off the lights and that hot spot goes away, then it's an ambient light problem. So shrouding it would work. So if you can just kind of turn off the lights, that'll do it. Shroud it. Or you can
sometimes the lab lights are dark and I'm just like, has the engineer gone home? And it's like I peek at it. Oh, nope, definitely still there, just testing.
but she's just taking a
Testing
nap
in the dark.
I thought about it once or twice.
Red's a good engineer, so he won't do that.
I never did, but I always, usually it's dark. You get tired. No one would know.
Yeah, especially because we paint or at least the one in Boston, we painted it black, so it's extra dark and it's windowless.
Yeah, there's a little dungeon in there.
Yeah, I call it the cave sometimes.
Accurate. But the other way to get rid of ambient glare is to overpower it with the intensity of your machine vision light. So if you essentially have your camera on and you don't have your machine vision light on and the image is dark, that means that your exposure time is so high that the ambient light isn't bright enough to, reflect off your sample and go into the camera. So it's not affecting it. And so then when you turn on and you flash your machine vision light, all of the light that's coming from that picture is from your, ring light. And so if there's glare there, then it's also a design problem, a machine vision glare problem. So those are probably the easiest ways to get rid of the ambient glare. When it comes to getting rid of the machine vision glare, you kind of have to do a little bit of a redesign sometimes, because that's where the way the light is mounted, it's reflecting in a way we don't want it to, and we have to solve it. You can do it by changing the uniformity of the light. So sometimes it can be as simple as just adding a diffuser or changing the emitting angle from narrow to wide, and that can kind of like remove the hot spot where it's causing a big problem. Or you can change the form factor. Lights like dome lights and coaxial lights, which kind of have lights coming from all directions, mostly dome, kind of coaxial. They will also get rid of the ambient light that Tommy woke up and he's crying really hard. So if you can hear baby crying, everything's fine. But so yeah, that will get rid of the ambient light, because it's just having the light come from all sides. So there's not one angle at which it's going to hit the sample and go into the camera, because the light is coming from all angles. If you don't want to change the form factor or the uniformity, your next best option is to put a polarizer on your light and a polarizer on your lens. And then the polarizer essentially cuts the direct light, and then it lets in the diffuse light.
We might be jumping ahead in the original plan, but you brought it up, so might as well talk about it now, which is polarization, which is one way to block out unwanted glare. If you want to do your regular little spiel about how it works, this is the perfect time to do that.
Yeah. So it's really actually, when I first started in machine vision like 10 years ago, I didn't really know how polarizers worked. I just knew that they did work. And you can kind of get by on that knowledge of just like, when I turn this the right way, it goes away and it's witchcraft. But like, you eventually learn that it's not. And there's a lot of physics going into it. Essentially, what glare is the unwanted direct reflection. And then what we want to see and what we're seeing is the diffuse reflection. So what a polarizer on your lens does, or on the light, is it sends the light out in just one direction. So if your polarizer is lined vertically, then it's just sending the light out in the wavelength going in one direction. So all of the wavelengths are coming out like this. And when it hits your sample, the specular reflection, that direct reflection, stays in that same direction and it reflects off. The light that is diffuse goes back to its original state of being circular. So we have only light coming down in one wavelength direction, hitting our sample, some of it staying in that direction, and some of it is circular again. And so then if we just had the one polarizer on the light and then it went up to our camera, we would still have the glare. But if we put a polarizer on our lens and we align it to be the same direction as the polarizer on our light, that wavelength that's being sent down in this direction is going to pass through in that direction. If we turn it 90 degrees, it's essentially saying, okay, I'm only letting through the light that's going horizontal. And so all of the light that is coming down vertically and reflecting vertically now hits this polarizer that's saying I only let through horizontal light, and it gets blocked because it's vertical. But so our image, you'd think our image is dark because it's blocking all the light, but it's not. It's taking all of that diffuse light that went back to its original state of being circular. So all of that diffuse light is hitting that polarizer, and all of the horizontal wavelengths are going through the polarizer to the camera. So that's how essentially it's working, that we can see the diffuse light, but we remove the unwanted glare. And that's why they have to be perpendicular to each other. So if you turn your polarizer, you can kind of see the glare kind of come and go as you line it up perfectly. That's orienting, what light are we letting through? What light are we blocking? So it's really, you have to have both or it won't work. And it's just kind of cool to think about as you're designing your system, how the wavelengths are just being adjusted as you turn a little knob.
I think I'll pull in a question that came up at our latest technical roundtable that relates to this. We hold in-person trainings once a quarter. We'll do it in 2026 again. Stay tuned. But the question that came up was, everybody gets confused about why you need both a polarizer on the light and on the lens. And this particular question was, well, why don't you just have it on the lens? Because that polarizer is just saying only let horizontal light through. And if unpolarized light hits the sample and, behaves how it usually is, shouldn't it still just let through horizontal light only? Is what I think was the logic of why that question was asked.
Yeah, I think it was. And yeah, you need both because you have to make them cancel each other out, essentially. So you have to have one be in one direction to block it in the other direction. If you just have one, then it's just going to let through it all. It'll decrease the intensity of everything. So that's the downside to polarizers too, is they will reduce the intensity because you're not sending 100% of the light and then you're blocking more of the light that you're not sending. So it usually reduces by about 50%. So sometimes polarizers don't work because you just don't have the right intensity to meet the exposure time that your vision requires.
What are the ways that you can solve and address for that?
If you're lucky, you can just overdrive it and that will get you enough light. If that doesn't work and you still need more, then you would have to step up to like a dedicated strobe light or try and solve it by using a different form factor or adjusting the angle. If it's like a ring light, you're kind of just, it goes straight down and you might have to switch to a bar light and adjust the angle so that direct reflection isn't going to the camera. It's going away from the camera, but you still can capture the diffuse reflection.
Actually, please elaborate on that. How does angle of incidence or even wavelength of light affect polarization and how well it works?
So the angle of incidence on a polarizer, I guess, well, there's two parts. There's angle of incidence and kind of glare and solving it when you're using, and then there's it with the polarizer. So which one do you want me to start with?
I will defer to your expertise. What feels right for you? Go by your vibes.
All right, we'll just write out the polarizer. The angle of incidence on a polarizer, the more important part is how the light is lined up to the polarizer on the lens and that those are perpendicular. So as long as they stay perpendicular and you do this adjustment, it should stay pretty polarized. And that kind of depends on the sample itself. Some samples you put a polarizer on and you're golden, you're not going to see anything. Some of them you put a polarizer on and still some of that glare will sneak through, but it'll be reduced or in a spot that you don't need it, or the polarizer doesn't really work in general. Some products are kind of have a polarization to them, so they don't really allow the direct light to stay in the direction that it's shined down on. They just kind of repolarize everything, so you can't really remove the glare. On some pieces, like Scotch tape, for example, at the right angle, undoes all polarization. Super silly. So when you come to angle of incidence, it's important, but it's kind of more application dependent on which one angle of incidence will matter versus the more important part of those two being perpendicular. If you're solving glare by just not using a polarizer and changing your lighting design, you have your lights set up, they're shining down, there's that spot where it is hitting your sample and going back up to the camera, and that's causing the unwanted glare. So if I take my lights and what we want to see is the diffuse reflections. So since it's diffuse reflections, the angle at which it's hitting the sample typically doesn't really matter that much if it's the diffuse that we're capturing because it comes out in all directions. So if you can just take your lights and adjust them a little bit, that light is now coming from, a little bit more to the side, hits the sample and goes away where your camera's here, the light's shooting this way. So now we're not capturing that unwanted glare, but we're still capturing that diffuse reflection because the light is still shining down and it's, scattering. So sometimes it's just as simple as, moving your light a little bit off to the side and removing that glare, stepping up, making it more uniform with more of a diffuser or wider angle.
So just so I'm clear, like, depending on the type of form factor, I guess you're using, sometimes it's just like using dark field instead of bright field, and that will block the unwanted glare. Sorry, you were talking about angles, so I started thinking about dark field.
Yeah, it still would be using direct light or light coming from overhead because dark field would change how the image is. Some defects can't be seen with dark field. They could only be seen with the bright field or overhead light. A low angle light wouldn't work for all of them. So it's not necessarily if you have glare, you go to a low angle light, which would be more of a dark field image. It's more just changing the angle of incidence. So instead of having my light be directly overhead and reflecting off my sample and going up, I'm just changing the angle. So now it's still overhead. It's just changing that angle ever so slightly. So when it reflects off, it misses the camera. It's not changing it so much that it's going from bright field to dark field, just a little bit off.
Okay, so still within the bright field range, but
Correct.
moving the angle within that. Okay.
Correct.
And then wavelength, does that have any impact?
It does. It's one of those things where theoretically it does, but it's not going to be the saving, when I step up to red, I won't have glare anymore. Like, that's not the case. But technically, light has a higher scattering rate at shorter wavelengths. So, like, blue UV scatters a lot more than, like, red and IR. That's going to transmit through. That's kind of why it's so unique in its properties. So, in theory, blue light, stuff like that, will have a higher scattering rate, might have a little bit more reflective properties versus the IR light would transmit through and not reflect off as much. So sometimes, you could reduce your glare by going from red to IR, but it kind of depends on the sample. Like if you're looking at scratches on metal, an IR light's still going to have glare just like a red light will because it's still it's not transmitting through the metal. But if it's a material that has a property that the IR can transmit through, it won't reflect off that like a green or red light or blue light would. So kind of, but not all the time.
Funny to think about IR causing glare because obviously we can't see it. It's never going to look really bright to us or anything like that. But that's the benefit of machine vision. And since we're still on the topic of filters, I figure we can also talk about the other type that you can use to block unwanted glare, which is bandpass filters.
I like that idea like 80% because it blocks about 80% of the light. When you have like ambient light, and this only works if you have a monochrome color light. So if you have a white light, this won't work. But if you have like a red light or a blue light or a green light and your light's shining down, you can put the same color filter on your lens and that will essentially let all of the wavelength through of the light that you have. So it'll let all the red light through from your machine vision light, but it will block off everything that's not red from the ambient light. but it'll still let through the red light from the ambient light. So it kind of takes this hot spot that you have that may be causing a problem where there's like 100% glare and reduces it to like a 20% more intensity than the rest of your image. So you can still kind of see like there's a brighter spot right there from the ambient light, but it might not be causing this big problem that the glare itself was causing initially. So it will improve it, but just having a bandpass filter only will never fully remove it, if that makes sense.
If you have an application in front of you and you think, oh, maybe I should test a filter to see if that improves it, are there certain characteristics of an application where you would say, oh, use a bandpass filter here, or oh, use a polarizer?
Well, polarizer doesn't work on ambient light. So if it's an ambient light glare, your answer would be shrouding, higher intensity light, bandpass filter, or like turning off the light if you can. And there, you could do a higher intensity light and a bandpass filter. That would work well together as well. If it is a design flaw where you're getting, that's when you would use a polarizer in terms of filter, but they don't solve the same problem. But kind of to elaborate, not necessarily related to glare, but this kind of came up at the last roundtable of sometimes it's really nice to just put the filter of the wavelength light that you have to cut out everything else. Because we were looking at an IR backlight with a bottle to see the fill level. And when we just had the backlight on, you could still see the text. And it was like a little bit hard to see. You could kind of see it. It was better. But when one of the people put an IR filter on it, it removed all the text because the IR light was able to pass through, but it was the wavelength of the lights above that were showing the text, not the IR light. So sometimes, especially with IR, if you add it, it can cut off the white wavelength where it's not really glare. That's the problem, but it's still the ambient light showing things that the IR light would be able to remove. So that one was a cool one to, yeah. I was like, oh, should have thought of that.
Student becomes the master. Okay, so we did filters and polarization in terms of unwanted glare, and you already touched on a lot of the other ways to solve for glare, so we can go more in depth on those. How about we start with shrouding, which, like you said, is just blocking the light from interfering. How do you build a shroud? Because I have no experience. You might have it from when you were at Keyence, but I'm just like, what materials, what kind of shape? If it's already an existing system and you're just like, we need to kind of finagle something in somehow, does it get like super DIY? Like, share some stories that you've encountered.
It's the whole spectrum. Like I've seen like duct tape, like cardboard boxes that they were gonna throw away, and they're like duct taping it like around, and like it did the job. And then there's people where, if you know your object is gonna be really shiny and reflective, there's a higher chance that ambient light's gonna be a problem. So when they're designing the system and they're implementing it from scratch, they'll just put in, putting stuff between extruded aluminum and like building around it or something like that. Kind of like how we hide stuff at the trade shows underneath the air hockey table.
Our dark secrets don't look.
Everyone's doing it. So it honestly varies from very like, okay, if you think that works, it will, I guess, to like, wow, it looks really nice. One problem we did have was it wasn't ambient light that was the problem, but it wasn't the way our light machine system was designed, but the machine that had our system get implemented in was really shiny. And so when the machine vision lights got put in there, they were reflecting off of the machine and hitting the sample and then causing glare. So it wasn't the ambient light, but it wasn't like the way the machine vision lights were designed. It was just the ambient environment creating more
indirect ambient light.
Yeah, it was super, and they were like mad at us because they were like, we set up your system and there's glare, and we were like, we showed you the images, there wasn't glare. And then we figured out that that was a problem. So then they actually had to take like a matte sticky paper and like wrap it around all the places that were causing it. So they would like hold up some cardboard, and if it solved the problem, they would like mattify that part of the machine and like hold it up, and then they'd mattify that part of the machine. So yeah, one was pretty DIY too, but just like a really interesting the situation that I haven't come across since.
Yeah. Funny lighting challenge. So basically, as long as you have matte material and a dream, you can shroud.
Exactly. Doesn't even have to be matte. It just has to be not see-through.
Not see. Oh, because you're letting light in. thought matte because you wouldn't want light to reflect off like a shiny material. And to your point, that's what caused the whole problem with that system.
Yeah, I get well, so matte if it's like the situation I just described where it's reflecting off the machine. But if it's from overhead and it's shining down, you just need whatever to block the
Oh,
light
yeah,
and you don't really care how it reflects off that.
that makes
Yeah.
sense.
So you're not wrong.
Yeah. Yeah. So glare, I've also heard of like glare shining off of people's like their protective gear, also, especially if it's white and interfering. So I've never seen it personally, obviously, but people who have been in this industry long enough have apparently said that can happen sometimes, which is kind of funny.
Yeah, I haven't heard of that one either, but I'm not surprised. Like anything can make an application harder, which is so fun.
That's the fun of this industry. Yeah, so shrouding, polarization, and then you already touched a little bit on increasing the exposure time. And I can't remember anymore, so might as well just reiterate what camera and lighting conditions need to change once you're like, okay, shortening the exposure time solves the problem of unwanted glare. What happens to the rest of the system as a result, or the hardware in the system?
Yeah. So if you decide to go the route of shortening your exposure time so it no longer is bright enough to let the ambient light have an effect, you need to get more light there. So you can either bump up the intensity. If you're at 100% and it's not bright enough, then you have to step up to overdriving your light. So depending on the controller you have or don't have, you would have to get a controller that allows for overdriving. And then once you do, if you overdrive it and that's successful, then that's kind of the easiest one where now you have enough light and you're getting the ambient light. You might also have to adjust the aperture of your system just to let in more light to get more in there. So it kind of can be a combo of opening your aperture to get more light in, making your light more intense by either just increasing the intensity or overdriving it, and then reducing the exposure of your camera. But you shouldn't have to do much more than that. There might be some like filters you could add, but ideally, if you can stick to those three things, that's going to be the most reliable.
In terms of like those three methods we talked about, how do you rank them in terms of effectiveness or what you would try or what you would recommend? Like, if you can work this in, you should do this solution versus like this is the least reliable solution.
Yeah, I would say if it's ambient light, the easiest one is to just shroud because then you don't have to make any changes to your system that could, change how it's working. If you can't shroud, then I would say increase your intensity and overpower the light. And if you can't do that, then add a bandpass filter if you're using monochromatic light because it'll help at the minimum. If it's a, machine vision glare, I I would say it's hard because sometimes like polarization will remove the defect also. Like it makes it so you can't see the defect. And sometimes the dome light will make it so you can't see the defect. Even like the LFXV can still glare sometimes, depending on the exposure time. So like ambient glare, even if you're doing a dome light. But oh, that's a good question. Like if I have the option, I would say if I have the option, I prefer to change the form factor or the placement of the light over a polarizer just because you lose intensity with the polarizer. So if that's the case, that's probably what I would do. But, if the dome light won't work, a polarizer is a great option and it does a really cool job. And it's really fun to see your problem just kind of go away when you just like turn a little, like, there, it's gone, everything's fine. And so, like, that's always fun too. So, not to say that it's a bad option, it's just the downside of it. Losing the intensity can kind of be a problem in some applications.
So if it's machine vision lighting glare, it's a lot harder to solve for.
Yeah, because, sometimes like changing the answer is to change the angle, but changing the angle no longer highlights the defect. Or, changing the form factor no longer highlights the defect. Or adding a polarizer, it's not bright enough. So I think that
Yeah.
one's definitely the harder of the two to sort out and figure out.
Something that kind of comes to mind in terms of applications are the ones where it's like a really wrinkly but super reflective like plastic bag or something, because those are samples we love to use a lot. But depending on what machine vision lighting you're using. It's just like a little bit of glare that still peeks through, and it differs from sample to sample because they have different wrinkles, or even if the orientation changes, if they're not all coming down in the same orientation, then it's just, a lot more unpredictable. And I wonder if there were applications that you couldn't solve because even if you could move a lot of glare, there was still like just enough left that you couldn't reliably, you know, make that system or implement a system because it just didn't make sense. It was going to fail too many times to make it worthwhile.
Yeah, honestly, okay, first of all, that was amazing. That was very much a student became the teacher. Like, that exact application has happened, and we've been doing this so much. I feel like you could probably give the next webinar.
Oh, I definitely could not.
You fooled
Unless
me.
you were going to do it for like humor purposes. Everybody laugh at Emily.
That's an idea. We'll put it in our back pocket. But yeah, there are applications, and the hard part with those, because like there was one where I was looking at cheese, like reading barcodes on cheese, and it would be great in one and not in another. The downside is a lot of times the field of view is too big to use like a flat dome light, the LFXV, or like, shell dome, because it's just they don't come in that size. And so you can use a flat dome light like the FE flat dome where it's, be a meter by a meter square, and you can even put a polarizer on that, so you kind of get the best of both worlds. But even then, that isn't quite enough to make it consistent. So there are definitely applications where even with all of the things we can throw at it, it's just still too reflective, too inconsistent that, it's just not really
Does that
reliable.
work, by the way? Because I know that the flat lights come with a polarizer option. Flat lights are inherently diffuse. So how is the effect different from putting a polarizer on really directive light versus more diffuse light? Or is there no real difference at all?
Yeah, there's no real difference. So like, let's pretend that this is my light coming down. This is a sample that I keep off to the side because that's what I do.
Always finding
It's like a 3-for-1. It's got blue and that. It's 10 out of 10. We're gonna keep this forever. Lunch.
totally side tangent tip for the listeners, but Lindsey, like super lighting nerd, if she's at the store and she like sees something like, oh, this would be a great sample, she just buys it. It comes out of the Sullivan clan monthly budget.
Why do we have this? I'm like, oh, it's a sample. I need that. I go put it in my office till the next time I see you. I'm like, look what I got. Just so embarrassing. It's okay. It's fine. What's embarrassing about it is how like excited I can get at the store. It's like, look at this one. It'll be so hard to solve. And he's like, okay, sounds good.
Good for you. Happy for you, sweetie.
It's very much like a proud mom. Like, okay, honey. But anyway, back to it. So if your light is coming down and it's coming down without a polarizer, and it's, more not diffuse and more, I don't know if collimated is the right word. It's going to come down. The way it emits from your light is it comes in a rotation. So it's the wavelength that comes out, like this, and it comes out like this, and it comes out like that. So it comes out in every which direction, 360 degrees. And that's going to come out whether it's coming out, because what a diffuser does is changes the emitting angle of it, makes it come out wider. So it's going to come out wide, or it's going to come out straight, and it's still going to come out rotating 360 degrees in any direction. So putting a polarizer on that isn't changing the emitting surface or how it's coming out, the angle that it's coming out. It's just changing where it's only coming out in one direction. So it can still be coming out in this direction, it can still be coming out in this direction, but it's all just coming out in said direction. So having a diffuser works because it comes out more uniform, and then putting a polarizer on that is saying, okay, so that uniform light will only come out in a vertical direction. Does that make sense? It's always kind of hard to explain with like my fingers and rotations.
I personally enjoy them, and I think it makes sense. So are diffuse lights with polarizers even darker than more direct with polarizers?
Yes, because the diffuse light will take, if you take the FE light at the highest emitting angle, the 10-degree emitting angle, and you put just the clear plate, you have a lot of intensity, but no uniformity. It's just all kind of one little hot spot. If you put the middle of the road diffuser, which is like a bar light diffuser, your emitting angle widens and your uniformity increases, but you lose intensity. The more of a diffuser you add, the more intensity you lose, but the more uniformity you gain. So it's essentially taking,
It's the whole image.
you're taking your, let's see, if this is my LED shining out and I don't have a diffuser, it's going to come out kind of at an angle like, 10 degrees. If I put a diffuser on, it's going to come out at like 30 degrees. And each one comes out at 30 degrees after the diffuser. Yeah.
Do you have any advice whether you would choose direct or diffuse light with a polarizer based on your experience?
It's all about what solves the application. You can,
So it's application dependent.
yeah. You can put it on, like the flat dome lights can get a diffuser. Even our coaxial lights, you can add a diffuser to. They've got a little, you can open it up and they're polarizer and diffuser, actually, technically. Yeah, you can put a polarizer on the flat dome lights and you can put a polarizer on like the coaxial lights, bar lights, ring lights. You can't put it on a dome light because the idea of the way that those work is it's just sending the light in all directions, so there's no glare in the first place. And if there is glare from a dome light, it's more than likely ambient light and not machine vision glare. So yeah, you can kind of try adding a polarizer to any light. We even have, like, you can buy sheets of polarizers and we have them in our lab and we'll kind of like cut them to the light size that we have. And like we'll put it in, that works. So if we don't have the specific polarizer that we need, or if it's like a weird light, we'll kind of try and make it work that way even. So one thing that you can't put a polarizer on, the HPR2, we get people asked to put a polarizer on that, and that doesn't really work because of how the light guide plate works. And then low angle lights don't really work for polarizer because the way that the light is coming, it's, like you have your ring light and you have your object, the light comes at such an angle that in order to polarize it, like the polarizer would have to be like sticks in too far and it would interfere with the image. So you can't really polarize low angle lights either.
I guess there's not much point to it either because of the dark field.
Yeah. Sometimes it comes up where you're like, because it would be like a glare on like the edge of it that you want to remove, catching the specular, or you're catching the the diffuse. So sometimes it's like, oh, this would be really cool to have, but it kind of can happen. You can reach out. It'd be like a custom thing. It'd be application dependent. So if you think that you do need a polarizer on a low angle ring light or the HBR2, we can talk about it, but it's not anything that would be like a standard product.
Yeah. Okay. I'll look forward to the day when that kind of application actually comes up. The engineers say, yep, we're going to have to make this thing. So yeah, if you learned anything new about machine vision lighting today, please give this video a like and subscribe to our channel. And you can follow CCS America, Lindsey, and me on LinkedIn. If you have topic ideas, you can send us a message there. Always open to it. And yeah, we'd love to hear it so that we can make this series more about our audience and what they want to learn about machine vision lighting. But thanks for listening, guys.